Okay, let's see if we can do it. We're going to explain why divisibility on the integers is a transitive relation. So here's the idea. Transitive is simple. If we call the relation R, that means that if A relates to B and B relates to C, then A relates to C. So divisibility, what we want to do is show that if A is a divisor of B and B is a divisor of C, then A is a divisor of C. And we have to remember the definition. A divisor is D is a divisor of a number, means that there is some integer k so that n is D times k. So I think we're ready to prove divisibility. Notice that here's what we'd like to prove. It's an if-then statement. So to prove a universal conditional statement, we always start with this. Suppose that A, B, C are particular but unspecified numbers. That's a typical generic argument, and the hypothesis is that A is a divisor of B and B is a divisor of C. And from that, what we'd like to conclude is that thus A is a divisor of C. So here's the hypothesis, here's the desired conclusion, and we just have to connect those with an argument. And since we have a definition at hand, let's unpack. So the first thing is to unpack. That means that B is A times K, and C is B times, we need another letter, how about M, for some integers K and M. And that's unpacking that A is a divisor of B and B is a divisor of C. What about unpacking that A is a divisor of C? That just means that C equals A times N, and an integer. That's really the definition of A is divisible. A is a divisor of C. So we need to prove this given this, and let's do that. Once we've unpacked it, it's really not hard. Note that C is B times M, and B is A times K. So B is A times K times M, and here's what we're looking for, A times N. So we can just use associativity. We should probably mention that, and then let N be K times M. Note N is an integer, as it is a product of integers. So C is A times N, N is that number, and we just showed that N is an integer, and that means that A is divisible, A is a divisor of C. And we're done, and let's put the almost there.
Daddy!
That's it. Okay, we're done with this problem.